I go by she or her pronouns. I'm based out of Chicago. So, woohoo, Chi-Town. And also, I've been with ThoughtWorks for about 2 years as a developer. So I'm going to go ahead and pass it to Samia.
Hi, everyone. I'm Samia Rahman. I also go by she/her pronouns from ThoughtWorks. I've been implementing data platforms and the data infrastructure for the last 3 years now, and also out of Chicago. So we'll dive right in and get started. So the first thing I wanted to quickly do is talk about or do a quick recap of what we had presented last year in relationship to data mesh, which is where self-serve data infrastructure really becomes important. So for those who are unfamiliar with data mesh, it is defined as a decentralized socio-technical approach in managing and accessing analytical data at scale. It works well for when your domains and enterprises are really complex and you need to take a very federated approach, unlike centralized data platforms, which are more fit for simpler domains where you don't really need to enable too many data product teams. A central team can handle the amount of data your enterprise is producing. So data in data mesh, as documented and articulated by Zhamak, who's the first person, or who's the person who put this notion together, the four core principles that it defines to make this really work at scale is that the first two, which is domain ownership and data as a product. Just like with any products that we build and we have customers, we're always looking to delight them. So the same notion here applies with treating data as a product and delighting the data consumers, such as data scientists, business analysts, et cetera, to drive out those intelligence from the organization. So we had done a simple webinar on this where we illustrated how a unit of a data product gets realized. And we had used Google Cloud Provider for the underlying infrastructure. The second part, or the third principle for data mesh is the self-serve data infrastructure, which is what we are here to talk about today. The webinar we had done last year was really to focus on understanding what a data product unit looks like and what are the core capabilities, and ensuring you have least privilege principle applied and you're accounting for multi-tenancy across any shared infrastructure that you want to make available in your data platform for these individual data products. And then the final principle that data mesh requires is the federated governance. Because you take a decentralized approach, you will need to ensure that you're doing your data security policies, semantic policies, access policy checks, and all the other details around governance in an automated fashion so that you can address the distributed nature of the approach. So for today, what we are going to zoom in on is self-serve data infrastructure. Before we talk about what that is, I'd like to quickly talk about what does that look in reality, a data mesh implementation. So the first thing is, in any organization, we have operational data collecting at the operational plane. That's where you have your microservices, maybe legacy applications, off-the-shelf products, et cetera, where the data is being acquired from your operational systems. Then this data needs to be aggregated and made available with the appropriate context so that your data consumers can actually leverage the value. So that's where the data mesh plane starts emerging. And then finally, that data product plane can be or needs a few core things, which is the self-serve data infrastructure. And that is encapsulated in the data product experience plane, where the goal is to enable the data product teams to be able to quickly deliver and realize their data product journey. In addition to that, from the data platform plane, you want to make sure you have a data utility plane. It's really just to do your build, run, and management. So mostly around your DevOps or data ops for the data products. And then there's the mesh experience plane. For any platform, you need to have centralized observability, monitoring, and also enable our data governors to apply those data security policies, the access policies at the mesh level across all those data products. So for today's webinar, like I mentioned, we will scope it down just to the self-serve data infrastructure experience, which is at the data product developer experience plane. The goal here is to abstract away all the data infrastructure needs and support that common data product developer journey. So moving forward, we'll look at what is self-serve data infrastructure and like why do we actually need to implement it. Then we'll talk about the approach of implementing it. We'll walk you through our thought process of evolving the code we had from last year, which was very hard-coded, to a more scalable solution, and then assess that solution and look at how we can scale it further. So let's dive into what is self-serve data infrastructure. A world without self-serve data infrastructure is an interesting thing to kind of take a minute to observe. As data product developers, let's say there is no self-serve data infrastructure, a typical pattern is I have to talk to the IT department in my company, do some design review of my system, and then I would have to establish some kind of system identity. This could be your application identity in the enterprise. And then finally, I would submit some kind of a request for a database. Let's say my use case requires a database. And sometimes I've encountered this in some companies, you have to talk to yet another team who will apply the network security around that database. So this is just four teams or 4 steps to get a simple database. And now imagine you as a data product developer, I will need orchestration, storage buckets, etc. And that adds on even more time for me to get started. So that obviously results in very high lead times to production. As a data product developer, I would be unhappy because I've developed all the code, it's ready to ship, but I can't get it out there. And then unhappy stakeholders and obviously missed opportunities for the business. So a world with self-serve data infrastructure is where the happy data product developers live. It's a world where in an ideal world as that developer, I would like a simple interface where I can say, hey, I need the database, I need the orchestration, I need the storage bucket. And when I hit apply, everything gets provisioned to me. It's safe and secure. I'm good to go and focus on my business logic, and I'm focused on delighting my data consumers. So in this world, the value proposition obviously is your lead time to production has diminished, and your data producers are happy, the stakeholders are happy, and we have a faster ability to deliver valuable data out there and enable our data consumers to also rapidly experiment. So now that hopefully I've convinced you on the value of self-serve data infrastructure and how it's crucial for the decentralized approach in data mesh to work, let's talk about how do we actually go about implementing self-serve. So this is nothing different than how you would implement products for external customers. You would adopt a product thinking mindset and treat your data product developers as internal customers who need that frictionless experience and a delightful experience with all the complexities hidden away. And when we implement self-serve, we also want to measure or establish some measures of success. And those could be monitoring the lead time to bootstrap for development, lead time to production, number of data product teams enabled, potentially the number of data products that are out there in the mesh itself. One key thing to note is you want to identify your early adopters here so that you can establish your pattern by which you're getting feedback from your customers and improving that self-serve experience. Again, very similar to what you do with any product development with customer-facing, external-facing customers. So the approach is exactly the same for the products with external customers, which is you discover your user needs, understand their pain points, define the personas, and try to create wireframes or workflows that they can kind of react to and give you or tell you that, sorry. Sorry, Stephanie, could we go back once?
Yeah.
Sorry about that. We would have to discover our user needs, and then we would define what those user journeys would look like, and again, reiterate with our early adopters to gain some confidence on that, and then actually go about designing what that interface looks like. So now we're getting into more concrete interfaces. What does the configuration language look like, or perhaps the API or CLI, or if there's going to be a user interface, what would that concretely look like? And then we go about delivering it, implementing it, and getting our MVP out there so that we can start doing user feedback testing and then reiterate through this entire process to improve the process. This is the mindset and approach by which we went about implementing it. So I will hand it off to Stephanie to talk about our thought process.
Great, thanks, Samia. So yep, let's go ahead and implement this. Okay, so our first step is, just like Samia had discussed, is to discover and define our customer. In this case, it's our data product developer. So we're going to make some assumptions first about this persona. We're going to assume that they're familiar with configuration as code languages, in this case, JSON, and version control systems such as Git. And just like any other product, we need to figure out their needs by asking questions to better serve them. So this may be pretty standard across the board, but we never want to lose sight of how to make a well-rounded product for a customer. So for our data product developers' needs, we want to ask, do they need structured data storage, unstructured data storage? Will they need data orchestration, or maybe data processing for transformations, and so on. Once we've kind of fleshed out our persona, we're going to go into the infrastructure design. So here we have two data products, one being data product A and the other being data product B. So one will be an upstream, here we see, and another will be a downstream data product. When we're looking at our data product A, we see that we have cloud storage, we have our identity here, our data product A service account. This cloud storage is obtaining data from an external data source. Here we have our cloud data storage for our data flow. And then we have our output data storage, which will be either BigQuery and or our cloud data cloud storage. Here we have for our consumers a consumer group, and we can see here that data product B's service account is connecting and is part of that group as a consumer of data product A. And since we are a consumer, we actually don't need the cloud storage that we have in data product A to store. We just need that access for our identity. So for our data product B, we have our cloud storage and we have the cloud data flow that we need for that. And then for our output, we only have BigQuery. And then if necessary, we have a consumer group for data product B to control. Okay, and now that we've discussed the persona and the infrastructure, we can now look over the design of the interface. So we have our data product developer here. So we're going to start from that workflow. We decided to go with a pull request workflow. And this is because it's the easiest to start up and create that self-service platform. So here, as a data product developer, I'm going to make that pull request with our configuration file, including our data product name, our storage inputs, our storage outputs, and whether or not we need compute. Once we've created that pull request, it will trigger off a validation pipeline to make sure that our configuration file is okay and ready for review. Once the pull request is triggered, we will also receive a notification as a platform operator here. Once I, as a platform operator, receive that notification, I'm going to review that pull request. If I need to, I will approve it or reject it, but hopefully approve and merge that on to our repo. Once that's merged on, we have a CI/CD pipeline that will look at what changes to the files were made. And when we detect that a new data product is added, we will go ahead and provision the infrastructure that was requested by our data product developer. Once that's provisioned, I, as a data product developer, will be alerted and I will get to continue to work with my requested infrastructure. Okay, now that we've discussed our persona, our infrastructure, and our interface, now let's look at how we're going to deliver this code. So when we go through our code, we're going to go through the code implementation by the platform developer. We'll first recap on the data infrastructure code from the past webinar. It's hard-coded. It only is provisioning data product A and data product B as we see it. But we're going to then look forward and see how we refactor that to more reusable modules to allow us to create more than just 2 data products. After we've done the code walkthrough, then we're just going to do a quick demo of what it would be like to be a data product developer and see their user experience. So let's go ahead and get into it. Okay. So let's start here. So like we discussed, we're going to go over the hard-coded version first, the first iteration of using Terraform. Here we have our main TF. Okay. And what we expect to see is just our data product A and data product B's resources just being created. Here we have our base infrastructure for both of our data products. We have Google Project Service, we have the firewall that's needed, and our compute network for our data flow. So if we scroll down, we're going to start with data product A. We have our service account. You can see it's hard-coded here for our identity. We have our data product A compute. We're just setting up the policies that we'll need to use for our service accounts, bind it to our compute. We scroll down here. We have that policy that we just discussed above, and we're going to go ahead and link it to our bucket that we're creating for data flow. Scroll down, we are creating our members, this being for BigQuery, our data flow developer, and the compute viewer. And once again, this is still for compute, and that's just creating that storage bucket. Okay, scroll down. Here we have our input or output storage policy, and that's just so we can go ahead and bind the proper service accounts to their appropriate roles, and we can later reference them. Okay, if we look here, this is data product A's inputs. Here we're just going to go ahead and create the storage bucket. You can see that here in this resource. And then following that, we're going to go ahead and link that policy that we just discussed, the storage bucket we just created for our inputs. Okay. And then for our outputs, we have a BigQuery data set. You can see here for our access, we have our owner as our data product A email. And then here we have our reader role, and that is using our data product B's email. Like we saw, this is our upstream data service. Data product. So that is why we have the consumer. And here's just a random string to ensure uniqueness when provisioning certain resources, so it goes smoothly. And not only do we have the BigQuery data set, we also have a storage bucket for our data product A's output. So here we're creating the storage bucket, and here we're linking that policy above to the output storage bucket. Okay, great. So that is all of data product A. So we'll just go quickly over data product B. Here we have our service account, so the identity. You can see hard-coded here as well. We have compute, we have the BigQuery job user, and this is creating that role and number. And here for our outputs, we also just have the BigQuery data set. You will take note that we do have the owner here, and that's linked to our data product B's email. However, we don't have any consumers of this downstream data product, so we did not need to add that consumer role. So as you can see here, it allows us to provision what we need for both of our data products, but it's still pretty rigid and not really scalable. And it doesn't allow itself to other data product needs. So let's go ahead and see how we refactored this. Okay, so let's take a look at the left at our directory structure. Here we have our base infrastructure. If you recall, we had a few things that we had to do to set up for our data products. So we go ahead and provision it there. We have a spot for our data products and then our modules. So this is the bread and butter of just refactoring, making sure we can reuse what we had. So here we have a BigQuery dataset, compute, data product, and storage bucket. So we're going to go ahead and look at data product. We're going to go into our variables. So this will be the main module that I use as a data product developer. So let's see what I will need to use this module. I'll need a data product name. Location is optional. It'll default to US. Here, I need to decide what inputs I need. It takes in a list of objects, one being the name and the other being the input type. And the input type, if you recall, we can either use a storage bucket or a BigQuery dataset. And just to verify on Terraform, we're using a validation on the input type itself, whether it be storage or SQL. And this is just to ensure that the data product developer is giving the correct information. Here in the outputs, it's a similar idea. We have our storage bucket as well as SQL, which is our BigQuery dataset. The only thing to take note is that we give a consumer email if we choose to do so. And that's just so our outputs can have that consumer or that reader role. Okay, here we have our compute and it's defaulted to false, but if we need to do some transformative data processing, we can go ahead and do that and turn that to true and get the proper infrastructure for that. And this is our project name and project ID for GCP. Okay, so let's go ahead and look at our main and see how that's all wrapped up. Okay, so we'll start with our identity. So we have our Google service account that we both needed created for our data products. You can see it's parameterized. We have our data product name. Here for compute, we have a module, and you can note here on line 10 for count of our compute, it will check if it's true or false. If it's true, it will go ahead and provision the infrastructure in this module, and if it's false, it will go ahead and skip it. Here's our SQL inputs, and that's just using that BigQuery dataset module. One thing to note is for the for each, if you recall, we've taken a list. So we're going to just iterate over that list and make sure we're creating as many BigQuery data sets that the data product developer requested. Okay. This is our storage inputs. It's the same idea, except we're just looking for storage buckets instead of the BigQuery data set. Okay, we scroll down. This is a similar idea as the inputs above, except this is the outputs. This will be the BigQuery data set output. And the only difference, if you recall, is we allow for consumers. So we have that down here on 53 through 55. And we scroll a little bit further, and same idea. This is just storage buckets outputs. We have the for each, and our owner email, and our consumer email. Okay, so that's everything to note for the data product developer and what they need to input. And this is just some of the outputs that will be triggered off in the pipeline to allow I, as a data product developer, to use my infrastructure. So that'll be the URL for the data flow bucket, my input addresses, and my output addresses. So now that we see how all of these modules are abstracted, let's go ahead and delve deeper into them. So we'll start in compute. So here, if I were to use compute, I'm going to need that project name and ID. I'll need a product name, location optional, and a data product owner email. I scroll to the top, that random string for uniqueness. The Google storage bucket will be the data flow temp. Here I have that policy, if you recall above, and you can see everything is parameterized. I'm creating those policies to bind those roles to, and the IAM members. So there we have everything encapsulated for compute. And we're going to go ahead and output that URL and self-link. Okay, now that compute is gone over, let's go over to BigQuery dataset. Here we have our dataset name, the data product name, our location is optional, our owner email, and a list of consumers and their emails if needed. You can see the default is none. Okay, so if I were to use my BigQuery dataset, this is the resource that I would be provisioning. You can see here, we're just passing through that owner email. And here we actually are using dynamic access since we're using this BigQuery dataset, not only for the input, but for the output as well. And it will create the access for the reader role as necessary with those emails that are given, making this more usable and dynamic. Okay, so that's BigQuery dataset. So we have one more, and that's our storage bucket. So let's look at that. So here we have the port name, data product name, location, owner email, that consumer email list, and our project name. Okay, so here that random string for uniqueness, the storage bucket that's created. The storage bucket is created. We have that policy that we're linking with the policy data in that storage bucket, and these are the policy data that are necessary in the outputs. So as you can see here, that's how we were able to create a more reusable and allow us to scale for more data products with Terraform. So now we're gonna step out of the code and we're gonna pretend now that I'm a data product developer and I wanna use this platform that was given to me to create the infrastructure that I want. So if I'm a data product developer, I'm gonna go ahead and start in my user README to see how I can use this wonderful platform. So I'm going to see here, I have some prereqs that I need to account for. So I need a GitHub account, and I'm going to need a GCP developer and consumer group. Once I've done that, I'm going to go ahead, fork that repo. I'm going to clone it. And then I'm going to go into my data products directory, as we can see here. Sorry, wrong one. In data infrastructure, I will go into my data products. I see here that I have a data product A and a data product B. So I'll just use the appropriate one, copy it over and rename. I will then update the main TF as well as the provider TF. I'll commit and push that up. I will then raise a pull request to the main repository. Once I've done that, it should then trigger the validate pipeline. And when I see that's triggered, I should just, as a responsible data product developer, I should make sure that that turns green so that when our platform admin is notified and they review the pull request, they won't have to ping me and say, hey, this is red, maybe you should do some checks. They will do their own checks once that's green, and then either approve or deny the request, and you will be updated with the status. So for the sake of time, I had already created a fork and cloned it, created a fork, cloned it onto my machine, and create the pull request. So here you can see I'm trying to create data product E as a data infrastructure user. So let's look at the files that I changed. So here you can see I'm in data infrastructure, data products, data product E, and then I'm changing my dev TFRs. This is just for GCP, my project name and my project ID that I want to provision my resources in. And here is my main TF. So if you recall, in the data product module, that kind of housed all of the smaller modules that I would use. So as a data product developer, I'm just going to use the data product module. Here, I'm just giving it my name, data product E. I have my inputs, which is just going to be a storage bucket named storage E. And then I have my outputs. So here I have not only a BigQuery data set, but I also have a storage bucket, and I'm going to give it the consumer emails as appropriate. Then I decided I need some compute power, so I'm going to turn that to true, and then pass the project name and ID that I mentioned above. Here are the outputs. I, as a data product developer, don't need to touch this. This is just so the pipeline can view and output appropriate values that I will then use to recall my infrastructure. Okay, so here is the provider TF, and the only thing I need to change here is if you look at line 9, data product E right here. We decided that each product should have its own Terraform state file, and this is just so it's more scalable and less expensive to maintain the Terraform state file, because if we shared one Terraform state with every data product, it would get quite large and quite expensive. So we decided each one should have its own state file. Okay, so that's what my pull request is looking like. So if I scroll back, look at my pull request, I'm logged in as my data infrastructure user. So I should still be able to see the pipelines that were triggered in Circle CI. If we go here, this will trigger off the generate pipeline. And this generate pipeline is just making sure that it's always going to trigger no matter what, but it's kind of deciding what needs to be done. So if we look back at our GitHub, we're going to say here is the validate data product E. So that was decided by the generate pipeline. We're going to look at the most important part, which is our Terraform validate. It looks green, everything looks good. So one thing to note about why we chose Terraform validate versus something like Terraform plan is because Terraform validate allows us to use Terraform init without a backend. And because we don't need the backend, we don't need to pass it our Terraform credentials to run this Terraform validate. So it gives us some sense of confidence that our data product developer has done things right, everything looks good. So that's why we decided to go with the validate. Okay, cool. So my job as a data product developer is kind of done. I need to wait, since I can't merge this myself, I need to wait for a platform admin to go ahead and merge this request. So I'm going to change hats now to an infrastructure platform admin. So let's go ahead and do that. So here I'm logged in as an admin. I see, hey, there's a pull request. Okay, I should have gotten an email as well. And I'm already here. I'm going to review this pull request. Everything looks green. That's great. I might, go and review my files, but I already know what that looks like. So I'm going to go ahead and merge this. And when this is merging, there should be another pipeline that's triggered. And you can see here, let's go ahead and running. You can see, okay, this generate, and see what it needs to run. Okay, great. So that's green. So let's go back. And then we'll see, like we discussed, it generates, it validates, and now it's planning the apply. So you can see there's kind of a workflow depending on where the pipeline is getting triggered and why it's getting triggered. So since it's on the main branch on the main repo, and it sees that in the data product directory, a new product has been added, it is go ahead and running that Terraform init. It's great. Everything looks good. So let us, you can see that we have the 14 resources are planning to add. So let's go ahead and approve that. It looks good. So that is the manual step 2 for me as well. Just making sure everything is good to go. Okay. You can see here, Terraform is just running. It's going ahead and creating all of those resources that we asked it to. Great. All right, thanks, Terraform. It's went ahead and applied all those and added all those resources. And these are the outputs, if you recall, that we didn't touch as a data product developer, but they were there. And this just allows me to go ahead and reference this if I need to do so. So now we see this all applied on our pipeline, but let's go for extra insurance to go ahead and look at our Google Cloud Platform. We see, okay, let's look at our storage. And if we can see here, data product E, since that's what we provisioned. Great, gave us that temp, data flow storage, our input storage, and our output storage. That's great. And just to verify our BigQuery data set, you can see right here, our data product E output data set. So with that, we're able to provision what we needed. And that concludes our demo. So let us go back to our presentation. So now that we were able to deliver that, let's be iterative and get some feedback and assess the solution we just provided. So some pros is it gets the job done. We saw that we were able to provision the infrastructure that I as a data product developer wanted to obtain. It was automated and consistent, and it also allows advanced users to provision infrastructure or provision custom infrastructure. Some cons are, we saw that it was a manual process with the approvals. So on the data platform admin side, there's some potential bottlenecking there. The users need Git and basic configuration or Terraform code knowledge. Ideally, they would need none. 3, the copy and paste model, as you know, can be quite fragile and result in user error easily. 4, there's some potential bottleneck with pull requests applied in sequence by the centralized pipeline. And 5, the user could accidentally point to another system and the Terraform state can result in locked states in the PR, which can be an issue. So now that we went over that, we're going to see how we can scale it further. And I'm going to pass that on to Samia.
Thank you, Stephanie. So based on some of the assessment we did, there are many ways we can evolve the solution and scale for the enterprise. So the first aspect to kind of look at is if we need faster bootstrapping of that data infrastructure and address those issues, we can introduce more validation logic to account for user errors, maybe even provide scripts or utilities by which they can generate their configuration with simple interface, and then have Terraform state file uniqueness. So those things can be caught during the validation stage. We can also reduce the approval bottleneck by removing approvals and allowing for provisioning to happen automatically. But this requires two key things. One is you need to account for your security such that data product developers can't actually access the provisioning secret by which that infrastructure gets provisioned. With Circle CI, there are certain limitations in terms of how you scope and apply granular permissions to the secrets, whereas there are other alternatives like Azure DevOps. I'm sure Jenkins, I haven't tried that, but you would be able to pull forward the Terraform plan during the validation stage and not compromise your secret. And then finally, because you're removing the approval gates, you would want to monitor for unused infrastructure periodically and destroy them with the consent of the user. So another alternate route, so we just observed that we have to do quite a bit of housekeeping to ensure more refinement to the solution and more stability in the solution. An alternative route could be that not only do you need the self-service capability, but you're now identifying that data product developers are not really familiar with Git. They're more, and they're unfamiliar with code configuration as code. There are a lot of tooling out there in the industry for low code development or applying just your transformations. So for those user groups, it might make more sense within your organization to adopt tooling like Terraform Cloud Enterprise, where they can use the same configuration language, that abstraction layer that we put, and leverage the underlying usable modules to make the infrastructure available to the data product developers. We've also seen ServiceNow being able to do that, and I'm sure there are other technologies out there. There's Pulumi, I believe, as well. Another point to kind of highlight here is that the abstraction layer, the language by which we implemented this interface, it's in Terraform. It requires a bit of Terraform knowledge, but it could be easily converted to lower level configuration code, and you can have a converter. I think Terraform now has YAML decode as well, so you can leverage that as well. And the parameters are also cloud agnostic. So our solution just showed it for Google Cloud Provider, but you can totally have storage in multiple types of storage inputs. If you want to go for a hybrid or a multi-cloud environment, you could have on-prem storage, you can have Azure storage or AWS storage for your inputs and outputs accordingly. So we'll wrap up with talking about some of the key takeaways that we want to highlight to you from our webinar. One, security is a first-class concern. Don't forget about it. We've oftentimes seen that that becomes a later concern, but you need to really account for it from the beginning. Don't compromise your secrets for provisioning. Make sure there are appropriate guardrails so that one data product team cannot access another data product team. So in the past webinar, we had showed how multi-tenancy and that can be achieved in Google Cloud. Another thing that we've observed is the pattern that we implemented and demoed usually is good enough in organizations. Most of the folks are familiar with that basic code. They're able to follow the user documentation and get it going. If you are looking to invest into it, I would suggest to question whether that truly does add value, or is it better to complete your capabilities, which we didn't show, or we didn't show all the capabilities that a data platform requires. So it might be better for you to introduce the data orchestration infrastructure so that data product developers can use that. They can apply data security and access policy as a separate capability, enabling your governors. And then finally, you can introduce reusable data ops pipelines to build, manage, and monitor data products. So those might be better investments if you are constrained on how much time you have to whether you want to invest in that self-serve or the capabilities. And then finally, the main message here is treat infrastructure as a product. That is the core thinking that really helps you implement and empower your data product developers. So to wrap it up, we have a list of resources that are available here. I think there was a question on the demo code. It's available publicly. There's an article in Infrastructure's product. If you want to learn more about data mesh by Zhamak, the articles are listed. There's a book also coming out, and you can always reach us at our email addresses. And I will pause there and open it up for questions. I see there was a question that was left in the panel. This one was around how will the custom code for the transformation get provisioned on the compute? So we didn't actually demo the transformation getting built and run on the infrastructure. We had illustrated this in the past webinar. The outputs you saw at the end of the provision pipeline, it had the data flow temp storage, your inputs and outputs. Those are going to be the arguments for your application that will implement or the application where you're applying the transformation logic. I hope that answers your question. Cool, it does, thanks. Talked about that. So the other question we have is, in all scenarios, devs need to have a little knowledge about infrastructure as code. Yes, to a certain extent. They don't necessarily, you can abstract away even the Terraform coding language and just simply give them a JSON configuration file that they fill out, or a user interface where they fill out the parameters. They do need to have understanding of what infrastructure is made available to them, but they don't really need to understand the Terraform infrastructure code, or if you're using Pulumi or CDK, etc. They don't really need to have the burden of understanding how the security policies, network policies, and the access management is happening. They can literally just apply the submit their configuration, and then things get provisioned. They use those outputs, and they can start focusing on writing the code. Does that answer the question? Cool. Sorry, I'm just looking to finish off. There are two more questions, or yeah, it looks like you have potentially different teams here. One that makes the reusable infrastructure modules, and one that can use them like a product, as you say. How is the responsibility handled if things go wrong, or from a support standpoint? Do you typically see the infra team handling this, or the data product teams gets familiar and helps? This is a really great question. In terms of the data product unit, or that the architectural quantum itself, one of the core capabilities that I had mentioned in the beginning is you want to make sure data product developers have the appropriate monitoring tools so that they can debug issues with their transformation logic, and their errors are typically going to be there's data quality issues, or when they were running their job, things didn't run appropriately. From the platform perspective, there could be some potential errors in terms of the infrastructure is not available. God forbid, the cloud provider has gone down or data has been lost, those kind of things should be then discussed with the platform team. Those become the responsibility of the platform team, and making sure that there are appropriate contingencies and disaster recovery plans to mitigate for those situations. So it's also important to not forget about yourself as the platform developer and operator, to introduce monitoring and appropriate cross-functional capabilities so that you can account for that when those kind of incidents happen. Sorry, does that answer the question? Feel free to let us know. How do you recommend approaching a refactoring of existing data infrastructure to self-service without disrupting upstream applications? This is a fun question. I think, or most of my experiences have been where we already introduced that lightweight self-service configuration. In terms of if you're looking to refactor all of that infrastructure code and your Terraform state is going to change, etc. And we are dealing with data here, so you cannot have data loss. That's a very key criteria to keep in mind. One pattern is new adopters, or you create a migration plan by which you provision new infrastructure, move the data out, and then your data product teams are on this new self-service platform. Or the alternative is you keep existing folks as is, and then your next generation of applications can continue to adopt the self-service, and then over time you can migrate them accordingly. But it does come at the expense of designing and implementing your migration strategy. So that unlike microservices, where you don't really have to worry about data migration, you might have an operational database, but there are easier techniques to do that. Over here, there's like S3 buckets or unstructured data, so you have to think about how you do that data migration based on the technology you're looking to make self-service. Does that answer the question?
Yeah, I think like the second question is also answered, right?
Mm-hmm.
Yeah. Okay. So I know we're closing in on the time. It's just 4 minutes left, but I personally loved the presentation, and it goes to show just by the amount of questions we got how much interest the topic had. So thank you so much to both of you, and a big applaud here to both of you for presenting this, and having obviously Samia for coming back and presenting again. And we hope that you can give us another chance and come back and present on any other topics that might come to your mind and that you might think is wonderful to share with the community. So yeah, thank you so much both of you for taking out the time today.
Thanks.
Thank you.
Thank you.
Have a good day, everyone.
Bye, everyone.
Bye-bye.
Bye.